Hello everyone, greetings and welcome to our webinar. It brings me great pleasure to have you all in attendance today as we explore an insightful program. Our speaker for this event is one of our well-experienced engineer, Ubaidullah, who has been an integral part of the KubeDB team for an extended period of time. As we commence, I'd like to highlight the importance of your involvement and contribution to this webinar. If you have any questions or queries, please don't hesitate to raise them in the Zoom chat, and we will answer them during the QA segment. Without any further delay, let's proceed to the program. I'd like to hand over to our speaker, Ubaidullah, who will provide you valuable insights regarding the topic. Over to you, Ubaidullah.
Thank you. Hello, everyone. Yet another webinar with me, and I am Ubaidullah. I am a senior software engineer at AppsCode. So I'm going to talk about simplifying provision KubeDB database with GitOps. I will talk about this topic a little bit. What is GitOps? And then I will talk about KubeDB database with GitOps. Then I will give a short architecture demo of our GitOps with KubeDB database. And then there will be a live demo. After that, our normal question and answer session. Let's dive into it. Okay, what is GitOps? I will basically give you a basic understanding, not a deep dive. Okay, GitOps is a set of practices that uses Git as the single source of truth for managing infrastructure and application deployment. It has some features and benefits, discussing one by one. Git-centric. GitOps is Git-centric, meaning everything, your infrastructure and application configuration, lives in Git repositories, and Git becomes the only single source of truth, making it easy to track and manage changes of your infrastructure. Okay, then automatic sync. With automatic sync, tools like ArgoCD, FluxCD, or any other tools consistently monitor your Git repo and apply changes to your infrastructure. This ensures your systems always the desired state defined in Git or any other platform. You can use GitHub or Bitbucket or any other Git platform actually. Then declarative. GitOps uses declarative approach. You define the desired state of your system in the simple file like a YAML, or it can be JSON, and the tools take care of your making changes, and no manual scripting needed for this. Then team friendly. It's team friendly too. Changes are made through pull request, and so your team can review your changes and collaborate with your code and ensuring better quality actually. Then consistency and reliability. GitOps delivers consistency and reliability by enforcing the desired state from Git. It minimizes errors, prevents configuration drift, and keeping your system stable. After that, enhanced security and compliance. It is a very important part of GitOps actually. Finally, in short, GitOps leverages Git's power to automate, streamline, and secure your infrastructure management. Okay, then how we can integrate GitOps with our KubeDB databases. New GitOps API. We have introduced a new API, gitops.kubedb.com v1 alpha 1, and designed specifically for GitOps actually for our KubeDB database. This API lets you manage KubeDB database directly with your GitOps. You can use tools like FluxCD, ArgoCD for that, and then simplified updates. Users edit the CR of your database of the API version gitops.kubedb.com and push the changes to the GitHub or any other Git platform, and it will actually check the changes of your actual desired state and actual states, and if any changes happens, it will create ops request or any other patch needed. The GitOps operator or our operator will do that. Automated workflow. Our GitOps operator does the heavy lifting. When you post changes to the CR in the Git, the operator automatically creates actual database of the custom resource. I will show you in the demo. You can see that. if it detects any updates, it generates the necessary ops request. It can be TLS authentication or a resource update or version update or any other ops request actually. User friendly. It eliminates the manual of request creation. It was our actual limitation in the previous kubedb.com/v1 API version. So we recovered that with this API version. Efficient management, streamline database operation, making GitOps workflows faster and easier. You can use GitOps to make your infrastructure changes faster and easier. So this is our actual flow of deploying database using GitOps. This is one prerequisite for this. You must need to install like ArgoCD, FluxCD to your Kubernetes cluster, and you have to sync your Git repo with that. After that, you can create or update GitOps here that specifies in the previous section. You will create the GitOps here. You can update also. Then GitOps operator will watch the CR, the resource actually. Then GitOps operator will watch and create the actual database for the specification. Then database will be monitored by our provisioner operator and create the necessary resources like ports, or if we enable security, it will create some secrets and it will create some PVC also. So then GitOps operator will also check the updates if update is happens or not. If update is happens with Git repo, the GitOps operator will detect the changes, and if some ops request is needed, GitOps operator will create ops request with referring the DB. Then when the GitOps operator create the ops request, the ops manager operator will watch the resource of ops request, and then ops request operator will post the actual our DB provisioner and update necessary stuffs like you can, if you want to update your version, it will update the version of your DB. If you want to change your resources, it will change your resources as well. So after that, it will update the necessary changes and restart the pods if needed. If do not needed the restart the pod, it will not, obviously. After the changes happens, it will resume resume our provision operator, and everything will be actual state and desired state will be same here. So this is our flow. If any other changes happens in that by the user, the flow will continue this way. So this is our actual flow. Now to use our KubeDB database and GitOps other stuffs, you first need to install KubeDB. Actually, you can install your KubeDB database using just a single help command. It's very easy to install KubeDB. If further guide, you can visit kubedb.com to see necessary stuffs like license or any other things. Okay. Now there will be a live demo actually. Before going to our live demo, we can create or we can install our ArgoCD. I'm going to use ArgoCD for the live demo. You can also use FluxCD or any other tools. Obviously, this is the installation process, or you can just visit ArgoCD documentation for more configuration related stuff. You can configure it. I have already configured my Git repo with my local, and I'm going to show you some demo how can you use our database with GitOps. This is my terminal. I'm going to show you my GitOps here. You can see that this API version is gitops.kubedb.com v1 alpha 1, and kind is same as our DB's custom resource. And all the specification you can see, all the specification is used that are used in actual KubeDB databases specification. So when you create this a simple CR through GitOps, it will copy the specification from it and create the actual database for you. So now this is okay, we can see the more details of specification. So you can see that the replicas is 1, version is 16.6, and the resource is here. We want to update this 3 section for our live demo and check what will happen, what is happen, or necessary things. Okay, first we have created our Postgres YAML, and we can you can create another DB with GitOps actually. So I'm giving a live demo with Postgres. Okay, first we need to push these changes to our GitHub or some other Git platform. I'm using GitHub for the live demo. Okay, let's push our changes to GitHub. Okay, we added git commit. Okay, simple commit message. No amend. Okay, we have committed it. Push order in main. Okay, we have already post. And after some times, you can see that the Postgres GitOps resource and Postgres actual DB resource will be created, and DB provisioner will create some necessary resources. Okay, let's wait some second. That okay. Yes, ArgoCD detect the changes from GitHub actually, and apply the changes in the in our cluster, and you can see that a GitOps resource has been created, and GitOps resource created the DB resources, and like a pod or something. We have specify replica 1 here, so we can see that the pod 1 pod has been come. Okay, the DB is now in provisioning state. Let's wait some second that we become ready. Okay, okay, you can see also the actual DB YAML here. Okay, yes, you can see the exactly same spec, the replicas 1 with some resources that we specify in the GitOps here, and the last thing is version. Yes, this is 16.6. Okay, everything is copied from the actually GitOps to our actual DB here. Okay, let's wait some second to become the DB ready. We can also see some other stuffs like DB creates other resources. PG, you can see ports. Here you can see what actually provisioner operator creates for us. It creates PVC, ports, secrets, etc. Actually, okay, it's still in provisioning. It is happening. Oh shit. It is actually from previous PVC. We have to delete this. I didn't clean up before. Okay. Get again. Okay. Now the PVC is one, so we clean the previous. Okay, let's wait some second. Pod is ready. Yes, DB is ready now. Okay, now we want to change some stuffs, or we want to update some thing. We want to update like version. We want to update Postgres version. Let's see what are the versions are available for to update Postgres. You can see lots of version. We want to just jump the next major one, so I will choose 17.2. Okay, let's edit our GitOps CR. Okay, this is our CR. We want to edit with next major update with 17.2, and we want to save and quit. And after that, we have changed our GitOps actually. So we need to push our changes to our GitHub or any other platform. So we are going to add our changes. We want to commit update versions with commit message. Okay. Yes, we have committed with update version message. Let's push it to our origin. Okay, post. After some second, it will create the necessary off request for us. Okay. Yes, we have updated version. Yes, you can see that the Postgres or GitOps operator has created a off request with version update. You can see. So let's wait the off request becomes successful. Okay, it will take some minute. Okay, we can see the specification of our off request. Let's see the specification. Okay, the specification database reference. The database reference is a Postgres, which is this, and the specification of our update version, a update version spec, and you can see the target version is 17.2. We have updated the version with 17.2. Okay. The optimizer operator is pausing and doing some necessary stuff for DB to be updated. We need to wait some minutes to become successful. The pod is terminating because we must need to restart our pod because we are updating version. So different image, different things. Yes, pod is running state and the off request is has been successful. You can see the status here. Okay, and DB also ready. There is no issues. Okay, we have updated our version and now we want to let's say update our resources. So which we can change our resources as well. Let's see, we have changes our memory to 2 gigs and limits also updated with 3 gigs. Yes, we can do that and save the changes and quit. We need to make we have to push actually our changes to GitHub. Let's git add, git commit, update resources with message. Now push to our git. Yes, it's pushing. Okay, it's already post. After some second, it will create another off request with like scaling, vertical scaling, you can say, because we are scaling the resources by vertical resources actually. Okay, let's wait some second and see what happens. Yes, you can see that ArgoCD detected the changes with desired state with actual state, and where there is a mismatch with resources. ArgoCD apply these changes to our cluster, and our GitOps operator creates the necessary off request for this to um, equal our actual state and desired state. Okay. The we can also see the ops request specification for vertical ops request. Let's see the specifications. Yes, you can see we have updated limits with 3 gigs and request with 2 gigs. Yes, we ops request created with the same resources. We have make changes to our DB. Okay. Yes, the Postgres ops request has been successfully completed with desired resources. Now we want to let's say increase our replica for Postgres, we can also load it, and we can also do some TLS with add TLS, remove TLS, update TLS, and update configuration also, and update and some other ops request that we support in KubeDB. We can do everything with GitOps using GitOps CRD actually. So let's update our CRD with replica 3 and 7 changes. Okay, let's push commit scale replicas. Now push the changes to git origin. Yes, it post. Let's wait some second to create another ops request with original scale. Okay. Yes, ArgoCD detect the changes and apply the changes to our cluster, and GitOps operator do the other stuffs. Yes, it is scaling. First we had one replicas. Now yes, it needs some other stuff, base backup and restore to the other replicas. That's why the port has come. Okay, let's wait some second. It's running. Actually, basically, there is a job. It's running. Yes, backup job is running for replication to other PG replica actually. Yes, this is for the replica 2 because we have increased our replica 1 to 3. So we need to backup our database for the remain 2 ports. So one backup has completed, the second is running. Okay, let's wait for the completed. It's running. Okay, yes, the last database backup has been done. I guess the first part is timing because uh, we are scaling from 1 to 3. This is actually first time we created Postgres with standalone. Now it is creating a replication with replication. So it need to be restarted because some configuration must need to be tuning for this part. Okay. You can see the restart obstacle has been created because some we are just scaling one port 1 to 3, so there's some configuration must need to be changed. So that's why actually we have passed the actual Postgres database and created the restart of request. It will take a few minutes to be completed. Let's add some minutes. The restart of request becomes successful. You can also see our horizontal scaling of request specification. Okay, sorry. Okay, you can see that the replicas was 3. Okay. Now it has been successful. Now our restart of request is processing. 2 port already has been restarted. Let's wait for the other one, the primary one. It is currently it is primary. Okay. Yes, the last primary one is restarting. It is in terminating state. Let's wait a minute. Still in terminating phase. Okay, we'll. Okay, body scripting. Here we can also change some like field config secret that will provide user provides configurations, and there's the other thing, authentication. You can see the field what secret. You can also update the secret, and the GitOps operator will create authentication of request for you. And also you can create TLS, add TLS, or remove TLS also. This is actually the thing. If any field that is that don't need ops request, the GitOps operator will directly patch the specification with the actual DB resources, so there is no issues. Every ops request is successful. So this is how you can use our KubeDB database on your GitOps workflow. That's the demo. Okay. Okay, current supported database. So we have supported lots of database in KubeDB. So there is a few database is currently supported using GitOps. Actually three: Postgres, MongoDB, and Kafka. We are going to support more database that supported KubeDB database actually in the upcoming release. That's all. And if you have any question regarding our webinar and our demo, you can ask me any questions.
So yeah, thanks Obadullah for this fantastic overview with hands-on demonstration. So from the audiences, if you have any questions regarding the GitOps workflow of KubeDB or maybe relevant questions, you feel free to ask in the Zoom chat, or maybe you can raise your voice and ask them in the meeting. We were open to your questions. So I guess there is no question at this point. Uh, Thank you all for the participation, and we look forward to your presence in our future sessions. Visit our website appscode.com/webinar to check the schedule and to register for our upcoming events. And wishing you all a very great day. Bye bye.
Thank you, everyone.